Alright, this is our next section in 12.3. This is on what's called inscribed angles. So before we talk about that, there's just a new term to talk about. We talked about tangent yesterday, which is a line that just touches the outside of the circle. Now we're talking about a chord. A chord is a segment who actually has endpoints on the circle. So you're going to find it inside. Kind of looks like if this were a banjo, the chords, the strings that would be on the banjo, they're on the inside of the circle. So it's just anywhere inside. It's a more generic term than like radius or diameter. A diameter is actually a chord, but it has to go through the center. So it's just a more generic term for that segment. So then the next one is what's called an inscribed angle. An inscribed angle is an angle whose vertex is on the circle and whose sides are chords. So if you look at the picture, here are the two chords. It's that angle inside the circle. That's what we call an inscribed angle. Okay? And then the other term is what's called an intercepted arc. An intercepted arc is the arc that is on the interior of the inscribed angle. So it's this section right here. That's what we call an intercepted arc. So the big thing today is talking about the relationship of the inscribed angle and the intercepted arc. So if you look at the picture on the bottom, if we were trying to find the angle in the center, this goes back to actually chapter 10, we did talk about this, that ends up being the same. So if it's in the center, it's the same as the arc. But look at what happens with the inscribed angle. If we pull it back farther here, that angle actually gets smaller, and it actually gets smaller by exactly half. So this ends up being 30 degrees. So then the formula ends up being that the inscribed angle is equal to half the intercepted arc. Okay, so now we're going to do some practice problems. So in one, we're trying to find the angle, and I like to kind of trace over these a little bit. We know that this angle is an inscribed angle, so it's half of that arc that's in the inside. So we're just going to take half the arc, and that angle would be 100 degrees. Then number 2, we're going the other way. We know the angle already. We're trying to find the arc. The arc is always the bigger thing. So to find it, this is where we have to actually make it bigger. So we're going to double 35. And the arc would be 70 degrees. And now these next ones are just going to make you think a little bit more. So first thing I'm going to do here is trace off, trying to find this angle. But in order to find that angle, we need to know the arc on the inside. It's not just take half of whatever number you want, it's always the arc that's inside of the angle. So the first thing we actually have to find is that angle. So you have to remember what you know a whole circle adds up to. A whole circle will add up to 360. So we're going to add the two parts that we knew that were outside of the angle, and that's 230. And then I have to subtract from 360 to find that missing part. That missing part, x, is 130. So x is 130. And then to find y, that's your inscribed angle. So to find y, we have to take half. We have to make that smaller. That's the part that's pulling away. So y is going to be 65 degrees. Okay? Alright, then for number 4, and I'm looking at that angle first. I like to trace over it, make it a little bit longer. I know the angle's 95, so I can find the arc here. The arc is always going to be double that, so I can do 95 times 2, and that gives me that arc is 190, which they didn't ask me for, but I needed that in order to find what the last arc of the circle is now I can add the two that I know. I can add 78 plus 190, which is 268, and then subtract from 360, and that tells me that that remaining piece is 92 degrees. So make sure you're using everything you know about the picture to help you find whatever piece happens to be missing. Alright, then this is just a couple of corollaries, a couple of additional facts that come from knowing that the inscribed angle is half of the intercepted arc. So the first one says, if you have two inscribed angles, looking at A and B here, and they intercept the same arc, that they're actually going to be congruent. So those would be the same. So if you look at example 4 is where this happens, is we have this is intercepting this piece, and the 28 also intercepts that same piece. So I don't even need to do the math there. I would just know automatically x is 28. But if you want to do the math, you could double it. You would double it, that would be 56, and then taking half of it would be 28. But the corollary just says that, oh, they intercept the same thing, they're going to have the same answer. So then corollary number 2 says an angle that's inscribed in a semicircle is going to be a right angle. So what that means is that if you see this angle and what it intercepts is exactly half the circle, that's half the circle right now, that has to be a right angle because it's half of 180. So if you look at number 2, the minute I see that this triangle is contained inside exactly half the circle here, I can automatically add a right angle. And then that's what's going to help me to find x. I can now do 90 plus 115 is 105. And then because it's in a triangle, I can subtract from 180. And that tells me that x is equal to 75 degrees. And then the last corollary deals with when you have a quadrilateral inside of a circle. What it says is that the opposite angles, so when it says opposite angles, that's like A and C, that those have to be supplementary. So angle A plus angle C would equal 180. And then B and D are also opposite, so angle B plus angle D is also going to be equal to 180. So looking at number 6, if I want to find angle X in the picture, I know that it's going to partner up with the one that's across from it, its opposite angle, and I can do 180 minus 57, and that tells me that X is 123. And then if I want to find Y, I partner that up with the one that's across from it, and those are supplementary, so it's going to be 180 minus 85. That's 95, so Y is equal to 95 degrees. Okay? The last thing we're looking at then is just a picture that looks slightly different. It doesn't look like an inscribed angle because it's not all inside the triangle. That's what happens when you put a tangent like we talked about yesterday. This is a tangent, and you connect it with a chord. This is the chord from earlier today. If you notice, the point is still on the circle just like it is with an inscribed angle. This is just a slightly different problem in this, a different looking setup in the second one, but that's still a tangent with a chord. And again, the point is on the circle, so it actually does have the same formula. To find the angle is still half of the arc. So if you look at number 7, if I want to find angle W and they're giving me that arc inside, again, it's this idea of here's the angle we're trying to find, this is the arc inside of there, then I can just take half of 246, and that tells me that W is going to equal 123. And then in the second example, I'm going to first trace off this angle because that's where the 203 is. The 203 is inside of there. So I can find X by taking half of 203. So that tells me X is 115. And then you can actually find Y one of two ways. You can say, oh, it's just the other side of the circle. So I can do 360 minus 203, which is 130. Or the other way to find it was to fill in this other angle down here by doing 180 minus 115. And you get that the angle is 65, but then to find the arc, you'd have to double that. So doubling 65 gives me 130 as well So these problems, there's usually one of two ways to find the thing that's on the other side. Alright, and then this is just a bunch of mixed examples here using the different properties we talked about. So for number 9, if I want to find angle A, again, the first thing I do is I trace around it just so I can get the visual on what's inside of it. The 108 is inside of angle A, but since it's on the circle, I have to take half. So angle A is going to be half of 108, which means A is 54 degrees. And then to find B, if I trace around that, it has the 60 inside of it. So I'm going to do half of 60, and B is going to be 30 degrees. In number 8, what you have to recognize is we have a quadrilateral right now. So if I have a quadrilateral, I know I can partner up the angles that are across from each other, and those are supposed to be 180. So it's going to be 180 minus 90, which means P is 90. And then to find Q, partner it with its opposite angle. Those are supplementary, so we subtract from 180. We get that Q is 122 degrees. Okay? In 11, I see this triangle here that is contained in exactly half the circle, which means the first thing I would fill in here is that angle C is going to be a right angle. That's actually the one I'm going to write first. C is 90 degrees. And then to find B, I can trace that angle B, and I know that the 95 is inside of there. So B is going to have to be half of 95. B is 47.5 degrees. And then the last thing we're actually finding here is A. A is over on this side. There's two ways to find A. You can look at it as being the other piece of that half the circle, which means we would do 180 minus 95. We get 85 degrees. Or if you wanted to find this piece of the triangle first, you could add 90 plus 47.5, subtract from 180, and this would be 42.5, and then you could double it to find angle A. So either way would be a perfectly acceptable way to find it. And then number 12, the first thing I'm focusing on is where that number is. If you're not sure where to start with where there is a number and trace it out like I have been. So if I want to use that 25, I can find A right now by doubling it. Since I'm trying to find the arc is the bigger piece, so I can do 25 times 2, and that tells me that A is 50 degrees. And then B, if I trace that, and maybe you don't see it right away, but you could trace along the outside here. That's half the circle. This is 180 degrees. So to find B, I have to take half of 180, which means B is 90. Also, by the corollary said that because that triangle's in half the circle, that would have to be a right angle. So either way, if you look at it and you see the 180, you have to take half of it. Or if you see that triangle is trapped in half the circle, that's automatically a right triangle. So you could have just put a right angle right there right away and said it was 90. And then the last one, angle C, if I trace around that intercepts the same arc as the last one, so that's going to be the same answer as B because they're intercepting the same spot. So C is 90 degrees as well. Okay, there's a few problems for you to try on Classkick just to make sure that you're getting a handle on this. If there's any that you don't get right away, please raise the yellow hand and I can explain it to you. These are a lot of like looking and thinking through, which makes this a little bit harder to understand. So if you have any questions, just let me know. And then you have a homework assignment to do as well.